Welcome to C++ Crash Course. In this course, we'll cover the core concepts of C and C++ programming. These are the two powerful and widely used languages in system software, game development, and competitive programming. You will learn the basics of C, the essentials of C++, the similarities and differences of each of these languages, the highlights on the properties of these two languages. It will help you translate smoothly from the procedural to the object-oriented programming language. So if you are brushing up the concepts of C and C++, this is a crash course that gives you a solid foundation in both languages. So this series is designed as a 9 set of videos, and we call each set of videos as shorts. So this is the first short of the coming up 9 shorts. And in this short of video, we'll talk about the basics of C and C++. We'll talk about typedef. We'll talk about hash-defined directives. We'll talk about how encapsulation is carried on in C and C++. We'll talk about the difference between object-oriented programming and procedure-oriented programming. So that is the basic overview of this video. Now, without further ado, let's dive deep into the main part of this video. Let's talk about typedef. Typedef is used to give another name for an existing data type. Here I have written typedef float price, which means I'm going to use price and float interchangingly. That is, price is another name for the uh, data type float. That is, I can use the words float and price interchangingly. If I want to define a float variable called a, after writing typedef float price semicolon, I can write float a semicolon or price a semicolon. So that is the use of typedef. It is used for better understandability by the user. Another concept you need to know is the reference variable. We can give another name for an existing variable. For example, I have defined a variable, integer variable a, for example. Okay, int a is equal to 3 semicolon. After that, I want to define a variable b that references a. In this case, I can write integer ampersand b is equal to a semicolon. Here I am using a variable b that references the value in a. Here a and b have the same address. This is how we give another name for an existing variable. Now let's talk about hash define directive. Hash define is a preprocessor directive. There are two types of uses for hash define. So hash define is a preprocessor directive that can either define a symbol or a macro. The first use of hash define is that it defines a symbol. For example, if we use hash define a 10, or for more clarity, I'll show you an example. Here, I have used hash define as to define the value in pi. Hash define pi space 3.1415. So here I am defining the value 3.15141592 into a symbol called pi. So this is the first use of pi. So after defining this, wherever we write pi in the code, for example, if we write cout pi, the compiler will replace pi to 3.151415 during the compile time. Another use of dash define is to define macro, as we have done in lines 6 and 7. Here I have given a macro called a macro name c underscore circ of x that calculates the circumference of a circle with radius x. Okay, that is 2 pi into x. And I have defined the macro named c underscore area of x that calculates the area of the circle of radius x. Now I have called both these hash define symbol and macro in this line 129. Okay, here I have written cout pi comma circ of a. Here during the compilation, the compiler will replace pi with 3.14 and this circ c underscore circ as 2 pi into a. Okay, this is the concept of hash define. Now let's talk about object oriented programming and procedure oriented programming. Object oriented programming is an approach that gives more importance to the data than procedure. The difference between object oriented programming and procedure oriented programming lies in their approach, data handling, modularity, reusability, security, and their real world modeling. So talking about their approach, uh, Object-oriented programming is based on objects and classes, while procedure-oriented programming is based on functions and procedures. Data is encapsulated within the objects in object-oriented programming, and data is exposed and shared across the functions in procedure-oriented programming. The modularity is high for object-oriented programming, where the code is organized via classes and objects. The modularity is low in procedure-oriented programming, where the functions and codes are more linear. Reusability is high in the object-oriented programming through inheritance and polymorphism, whereas reusability is limited in the procedure-oriented programming because of they are mostly through the reuse is mostly through functions and reuse. That is function reuses. The variables are more secure. That is, in object-oriented programming, the data through data hiding and data access control, the data is more secure. Whereas in procedure-oriented programming, there is less security because the data is globally accessible. Object-oriented programming is better suited for real-world entities, uh, whereas for procedure-oriented programming, it is harder to map real-world concepts directly because it prioritizes more on the procedure than the object. Some examples of object-oriented programming languages include C++, Java, Python, and C hash, whereas procedure-oriented programming, some languages examples include C, Pascal, and early versions of BASIC programming language. Object-oriented programming is best when your project involves complex systems with interacting objects, whereas procedure-oriented programming works well for simpler linear tasks like scripts or small utilities. There are five basic properties of object-oriented programming. They are encapsulation, data hiding, data abstraction, polymorphism, and inheritance. Data encapsulation is a property of grouping related data and associated functions as a single unit. That is, I'll repeat, uh, encapsulation is a property of grouping related data and associated functions as a single unit. In C++, it's implemented using class. Data hiding is a process of hiding some data inside the class so that they cannot be accessed outside the class. In C++, hiding is done using private and protected access labels or visibility modes or visibility labels. Data abstraction is an act of representing essential features without showing background details. Through public member functions, we can access hidden data. I'll illustrate all of these properties in the live example shortly. Polymorphism is another property of object-oriented programming where different objects of same classes behave differently in the same situation. Inheritance is where we can derive new classes from an existing class so that the second class can have properties of the first class. I'll also illustrate this in the example. Now let's talk about classes. I'll explain the properties of OOPS, that is object-oriented programming uses using classes. Now let's talk about classes. Class is a user-defined data type which group related data and associated functions as a single unit. There are two types of members in a class, that is data members and member functions. All objects in a class share the same member function, so its memory allocation is done only once. That is at the time of class definition. But for the storing data member, each object needs separate memory allocation. Memory allocation for data members is done with object declaration. While defining a class, there is something called as access labels or visibility mode. They are the keywords which define or determine the accessibility of the class members. They can be private, protected, or public. By default, the access label is private for classes. For private and protected members, the scope is the class. By default, the class members are private. For private and protected members, the scope is the class. But for the public members, it depends on the scope of the object. That is, for local object, scope of the public member is the function. And for the global, it is the entire program. That is, we can create a global object only for a global class. Some key differences between object-oriented programming and procedure-oriented programming are that object-oriented programming is a top-to-bottom approach, whereas procedure-oriented programming is a bottom-to-top approach. Why? Because in object-oriented programming, we focus more on the data types, and how we group the data so that we can call each data and we can call each set of data as a single entity. For example, we can group the properties of a book as a single entity using classes. In object-oriented programming, we have features like encapsulation and inheritance, while it is absent in the procedure-oriented programming. Data abstraction and hiding makes the object more safe in object-oriented programming, unlike the procedure-oriented programming, where these features are absent. Now let's talk about structure and union. Structure is a user-defined data type that groups variables of different types under the one name. Each member has its own memory in a structure. That is, in a structure, each member gets its own separate memory, and it is useful when you want to store related data together. Now, talking about union, union is like a structure, but all members share the same memory location. Only one member can hold a value at a time. That is, the maximum size of a union is equal to size of its largest member, whereas the size of a structure or a class is the sum of the sizes of all its member functions and member uh, variables. Union is used when you need to store only one of many possible data types, but only one at a time. We can only store one property or one variable at a time for a union object, but we can have data types, we can have variables of any data type in a union. We can have many variables in a union, but we can only use one variable at a time for a union object. Talking about the differences of structure, union, and classes in C language, structure and union are supported in C, whereas class is not supported in C. That is a main difference. Each member has its own memory address or memory allocation in case of structure, but all members share the same memory in case of a union. Union store different data types in the same memory. If you have a union object, uh, they store different data types in the same memory, but a structure group related data. If you talk about C++, structure and union has default access type as public, whereas a class has a default access type as private. Therefore, we have to explicitly define that uh, if uh, if you want a member to be public, we have to explicitly define that member to be public in case of a class, so that we can access that function or a variable in the main function or other functions outside the class. Inheritance property is supported only in structure and class. It is not supported in union. Member functions are supported in only structure and class. It is having limited support in union. We cannot have much functions in union. For structure and class, each member has its own space, whereas in union, all members share a same memory space. A structure is used for lightweight data structures, whereas a union is used for efficient memory for one of many types. Class supports full object-oriented programming approaches. Now let me illustrate the same using an example. In this example, I have shown you about this hash defined directive. I've defined a symbol and a macro. Now let me show you the classes structure and union. So I have included these three header files: iostream, ctype.h, and string.h, because I'm using functions from these header files. I'm using uh, namespace standard because I'm using the standard functions in C++. Now I am using a typedef float price, so I am using float and price interchangingly. Now I have defined a structure called bookshelf underscore s, and it defines all the characteristics of a book. That is the name of the book, the publishing year of the book, the version of the book, the category of the book, and the publisher name of the book. Now I have defined a union called bookshelf underscore u that talks about the reference number, the book code, and the serial number of the book. I am using only either of these variables. That is, only one of these variables will be used at a time. Okay. A book will have either reference number or a book code or a serial number. Not all or not two of these. Only one will can be used. Okay. After that, I'm having a class called bookshelf underscore c that has objects of the structure that I have defined, the union that I have defined. The structure is having the properties of the book. The union is having the unique code of the book. After that, I have a float variable called actual price. So I have used price as a data type here. After that, I have a float variable called discount percentage. After that, I have a float variable called sale cost. After that, I have a integer variable called unique. This variable unique is basically to determine which unique code is being used. If this variable unique c is 0, that means the unique code is not defined for that book. If the unique c is 1, that means reference number is used as the unique code for that book. If the unique c that variable is 2, that means book code is used as a unique variable for that book. And if the unique c is 3, that means serial number is used as a unique code for that book. Now I have another function called cost calculate. This function calculates the cost of the book from the actual cost and the discount percentage. Actual cost minus actual cost into discount percentage by 100, and I return the sale cost through the cost calculation function. Always remember that the structure members are always public. Union members are also always public, whereas the class members are private. So when I call this structure and union here, these guys are private. Okay, these guys can be used only in the member functions of the class and not outside the class. Okay, now I am defining some public functions. Public functions like showing. Uh, in the show function, I can show the properties of the book, like the book name, publisher, the publishing year, the version of the book, the category of the book. Okay, I have to rename this. It's a version of the book. It's the category of the book. Category of the book. It's the publishing year of the book. It's the publisher and the book name. All right. Now I have another public member called as edit that is used when I need to edit the discount percentage of the book. So here I can call this function with the new discount percentage, so that the discount percentage of that book will change, and consequently I'll calculate the cost, that is the sale cost of the book, and I'll display the change uh, in the I'll print that the discount percentage for this book is changed from this percentage value to this percentage value. After that, I have a function to add the book. So using this function, I can add each book. It asks for the details of the book. What is the book name? What is the publisher name? What is the version? What is the category of the book? After that, I'll ask for the unique code. Uh, I'll assign the unique code like this. That is, uh, if all the characters in the unique code are digits, then I will assign the unique code to reference number. For example, you can see that here in this if condition, I am saying if all the n stores the number of digits in the unique code, a stores the number of alphabets in the unique code, and if the number of digits in the unique code equals to the length of the unique code, then I am storing the unique code to the reference number. And if the number of alphabets in the Unicode equals to the length of the Unicode, that means all the characters in the Unicode are alphabets, then I am storing the Unicode to book code variable in the union data structure. Okay. And if the Unicode is having a combination of alphabets, digits, or even special characters, I'm storing it to serial number union variable. Okay. And if there is a space in the unique code, or if the number of characters in the unique code exceeds 20, because I'm assuming that all unique codes will be having a maximum length of 20. So and also I assume that there should not be a space in the unique code. So if either of that condition is violated, I'm saying that this is not allowed, and I'll be going back to fetch the unique code again. All right. So after that, I have a function called as calculate the amount, that calculates the sale cost. That is, I'll get the value of the actual cost, the discounted percentage, and after that I'll calculate the sale cost using the cost calculate function, because cost calculate function is a private function, whereas I'm defining this cost amount function as a public function. Since cost calculate function is a private function, I have to use this cost calculate function in the in the functions member functions of the class, because I cannot use this cost calculate functions in the int main function. Okay, because it's a private function. After that, I have one more function in this class called as fetch cost, that just displays the uh, that just returns the sale cost. So I can use the this function to fetch the sale cost and display it somewhere. So in this main function, I have first illustrated the hash defined directive. After that, I have asked how many book has to be added in the record. That is, how many books are there in your stock. So if I say two books, then it will ask the details of two books. If I say one book, it will ask the details of that book. So I can just build the code and run it. Then it will ask how many books are there in your stock. I'll say one book. I have one book in my stock. I'm asked to enter the name of the book. Let me write Oliver Twist. Okay. What is the publisher name of the book and what is the publishing year of the book? I'll write 2025. Publisher name of the book, I know due to some bug that is not asked. The scene function got skipped basically. So after that, it is asking the version of the book. After that, the category of the book, I'll type fiction. Then it is asking the unique code. Now it's asking the actual cost of the book, 345. Discount percentage is 10 percentage, and says that the book can be bought for 310 rupees. All right, right. Now, as you can see that uh, how it worked. So since I only needed one book, it asked for one book, and after that, it asked about the details of the book and then calculated the cost and displayed the cost using the fetch cost function. Now, in this example, you can see that I haven't used this calculate cost function in the main function, right? In this int main function, I haven't used this uh, cost calculate function, right? That's because it's a private function, but I have used this function in the public functions of the class, right? So this is what is called as data abstraction, because I have used this function as a pub, uh, private function and used this function in the member functions of public member functions of the class, so that I am basically abstracting this function from the main function. This function will remain as an implementation detail. This function cannot be directly invoked in the main function. That is called as data abstraction property of object oriented programming. Also, when I used these private members in the class, for example, I have used all these properties, unique code, actual cost, discount percentage. All of these are private members of the class. This is how I implemented data hiding in this class. This is another property of object-oriented programming. So we talked about data abstraction and data hiding. Data encapsulation is when we group all these functions and members as a single chunk using this class function. Okay, we have identified all the properties, the unique code, the cost, and all the member functions of the class of this book as a single entity using the class data type, right? That is called as data encapsulation. Polymorphism is when you can use different functions that behave differently at same situation. For example, there may be different objects of the same class that behave differently in the same situation. For example, I can say uh, I can write a member function called as void add book. Okay, that has an argument called int sorry, character, okay, of of character A of 20. Okay, so this argument basically fetches the name of that book. Okay, let's write the function so that this the book name will be directly fed with this argument, and then after that I'll fetch all these arguments. If we write another function like this exactly is called as polymorphism, because there is a function called as add book, but if we give an argument to that function while we call it in the main int main function, the int main function, if we call this add book with a twist book, if we write like this, then this particular line, that is one line number 142, will call this particular function. But if I did not write this argument for this function, this line number 142 will call the other function, this function, line number 62. Okay, this is called as polymorphism. There is another concept called as inheritance. Okay, inheritance is when we call a we define another class as a child class of this parent class. For example, I'm defining class. Okay, story stories inherited from public self underscore c. All right, this is called as inheritance. Now I can just write. Now I can just define this class. Okay, but I am defining this class as a publicly inherited from this bookshelf underscore c. That means it will have all the properties of this bookshelf underscore c with some additional functions or members that I'll be defining here. Since I'm defining everything public here, all the public members will be public, all the private members will be private, and all the protected members will be protected in this derived class also. I can also inherit a class as private, which means all the members of the parent class will be private for this derived class. Can also define the member as protected, which means the protected members will be protected, public members will also be protected, private members will be private for this derived class. So this is the concept of inheritance in object-oriented programming. So I have illustrated all the properties of object-oriented programming in this session. So this will wrap the session, and thanks for watching. Let's see you with the next video. Thank you.